Welcome and hello. This is a video tutorial in HEC RAS, and in this lesson, I'm going to be discussing geometric data, specifically entering and editing Culvert data. So in the previous lesson, we dealt with bridge data. This is now Culvert data. There will definitely be a little bit of overlap with lesson 5. This is lesson 6. Here we go. On the screen, I have HEC RAS. I've got a project file and a geometry file. I have the geometry data editor already opened up. So open that up, you would just go up to edit and then geometry data, geometric data. All right, what I have here sketched is a river reach. It's 300 feet long, just a straight line from north in the southward direction with 4 different cross sections every 100 feet, every 100 foot of stationing. So here is the cross section data, nothing too fancy here, just increases at a 1% slope. And then let's go ahead and start by clicking on this bridge/culvert button over here in the editor's toolbar. All right, that opens up right here. We have the bridge culvert data editor. And before we already saw deck roadway here, sloping abutment, and that was in lesson 5. Now in lesson 6, we're going to talk about culvert as well as a few of the menu items, view and options. So first thing we need to do is actually create the culvert. So to do that, before we click the culvert button, we're going to go up to options and then add a bridge and or culvert. Okay, what I'm going to do is put this culvert right in the middle of the reach at station 150. So I'm going to type in 150 here. So click OK. Now what I see in this display is the upstream end and the downstream end of the bridge. Well, it's calling it a bridge. It's a culvert. The next step is to click on the culvert button right here. And now we have our culvert 1. It automatically defines culvert 1. We don't have to click the add new culvert button right here, but we could if we wanted to add a second culvert. These buttons along the top here is create new culvert. This next one is rename, delete, and copy, which feels a little bit inconsistent with the fact that these buttons are labeled with icons instead of the words. So for instance, if I click on here, we have add, copy, and delete as the word itself is on those buttons. And then same with sloping abutment, add, copy, and delete. But anyway, for culvert, we have icons. This is new, rename, delete, and copy. Before I define the details of the culvert, I first want to go ahead and specify the distance and the width of the culvert, and I want to see it in the plan view as well. That's one thing I didn't do with the bridge. So I'm going to click on deck/roadway, and for this selected culvert right here, station 150, we're calling it, the distance right here is going to be 30. That is the distance upstream from the next downstream cross section, I believe. We'll go ahead and confirm that in just a moment. And then the width I'll say is 40, right? If not 440. So let's go ahead and just click OK to that. And then I'm going to save, or it's automatically saved. So I'll click and close on the bridge culvert data editor. And then right here, we have our bridge culvert icon. We can see this grayed out right here. And it shows river A, reach 1, and then the direction of flow. I'm going to click on the bridge culvert once again, and then click on road deckway. Now, if I change this 30 to say a 20, and then click OK, then that would update. Okay, yeah. So what that first distance is, it's the distance between the downstream face of the structure, whether it's a bridge or a culvert, and then the next downstream cross section. So now the distance here is 20, this distance is 40, and this distance is 40. I want to change it back to what it was. So yeah, we'll have 30, 40, and 30. So bridge culvert. This is my only structure. Deck roadway, and I'll change this back to 3, and then OK. Okay, and then if I close this, it updates the image. That looks good. Go File and Save Geometry Data. Okay, let's go back to the bridge culvert. Now we can click on the culvert button. This editor is where we'll spend most of our time in this lesson. We're going to talk about the parameters, what they mean, and then make some edits to define our culvert here. The solution criteria is a drop-down. We have 3 options, either computed flow control, inlet control, or outlet control. If you know for sure which one it's going to be between inlet and outlet, you can select that. If you're like me and you don't, you can just leave it at the default, which is computed flow control, and then let the HEC RAS make that determination. After that, we're going to have a shape. So keep in mind, when we're defining a culvert here, this is really a culvert group. Culvert group 1 is what we're defining. So the shape is going to be the same for every culvert in the group. as well as the dimensions and the other properties. That way, you may have 5 culverts, but only one culvert group if all 5 of the culverts share the exact same properties. All right, so for shape, our options are circular, box, pipe arch, ellipse, arch, and so on. I'm not going to read them all here. You can scroll down for a couple others. And then whatever you select here from a shape, then you'd have to define the dimensions. So for instance, if it was circular, I may just say 4 feet. I believe this is in units of feet. It doesn't say that here. It doesn't say it in the user's manual. Rise of the culvert. Basically, what it's talking about is the shape of that culvert. Okay, if I selected box, for instance, the labels would be span and rise. Span would be width, and then rise would be height. There we go. Okay, I'm going to start off by just using circular for this first one, and I'm going to say it is a diameter of 4 feet. All right, this project is using US customary units, so I'm pretty sure it's feet. Below that, we have a chart number and a scale number. The chart number is used to select the Federal Highway Administration chart number that corresponds to the type and shape of the culvert being modeled. And similarly, with the scale number, this is the Federal Highway Administration scale number that corresponds to the type of the culvert entrance. So right now, these values will change based on the shape that we select. So if I selected box, for instance, then these numbers change. And what it is it's just a different list of options. So if I select circular, the first option, then I have the different chart numbers, 1, 2, 3, 55, and 56 that correspond to circular culverts. And then based on the chart selection, that will update the list of options to choose from on the scale. The user's manual does have a link to the Federal Highway Administration scale and chart numbers right here. I will leave a link to this page in the description of the video as well. So if you scroll down a little bit, then you see chart numbers and scale numbers and then descriptions after that. So the chart numbers increase from 1, 2, 3, 8, 9, 10, and so on. It goes down for quite a ways. And then within each chart number, there's a number of different scale numbers. So that's why we have sort of a breakdown and 2 different drop downs to control exactly what sort of culvert that we are selecting. I'm not going to get into the details of all of this. It's a little bit beyond the scope of the lesson, but I'll just go ahead and make a selection anyway. So for circular, I'll just go ahead and say concrete pipe culvert, and it'll be this first one here, square edge entrance with head wall. Distance to the upstream cross section, I already know that based on my diagram, that's going to be 30 feet. And then the length of the culvert is going to be 40 feet. The entrance loss coefficient, I'm going to say is 0.5. If you're interested in these sorts of technical details, you can click on this link right here. It should open up a link to a description and a discussion about different head loss coefficients and so on. Okay, I'm just going to go with 0.5, exit loss coefficient of 1, and then a Manning's N for top and Manning's N for bottom. So this is the roughness coefficient. I'm going to say the top is 0.013, and then the bottom is 0.015. I'll assume that maybe some erosion has taken place and the bottom half of this concrete culvert is a little bit more roughed up. Where that threshold is, where that boundary is between the bottom N and the top N is defined in this next field over here, depth to use bottom N. Now, if this is a 4-foot diameter culvert, then the number would have to be between 0 and 4. I'll say 1.5, for instance. So for the depth of up from 0 to 1.5, that will use Manning's roughness of 0.05, and then above that, it'll use a roughness of 0.013. Depth blocked. This field is used to block off a portion of the bottom of the culvert. This blocked out area persists the whole way through the culvert right here. So for instance, if there was debris in the culvert or whatever, maybe just some buildup of whatever, that I assume was also in units of feet. A lot of these parameters here are in units of length, but I'm still kind of guessing on what the units are. All right, upstream invert elevation and downstream invert elevation, obviously very important. If I look at my cross section here, I'm going to say the invert is 40 feet. And then I'm going to also say that I have 2 different culverts. So there are going to be 2 circular culverts right at 40 feet. And right now I'm viewing both the upstream and the downstream, but that's probably not necessary. All right, so I'm going to type in 40 here and 40 here as well. Now down here, we need to define the number of barrels and then the center line of those barrels, both upstream and downstream. So this is like the number of individual culverts within the culvert group. Now, the number of barrels right here, this is a read-only field. You can't like type this in, but what you can do as a modeler, as a user here, is to type in a barrel name or a culvert name, and then as you do that, the number of barrels will increase, and then once we save it, our display should update with our culverts. So let's just go ahead and start typing. I'm going to say culvert 1, enter, and it's going to have a upstream and downstream station of say 44, so 44, and then culvert 2 will be 50, 55, and 55. Okay. The barrel GIS data is not required for purely 1D bridge or culvert crossings. I'm going to type it in anyway here. So I'm just going to go 0, 40, and then 0 and 40. I think that's right. Okay, so anyway, once we click OK, then that's going to save the changes, and it should update our diagram here in the Bridge Culvert Data Editor. So let's see what happens. Okay, that looks good. So they don't look circular, but that's just because the scale is off. We're going from 0 to 100 here in about 4 inches, and then 0 to 100 here in about 2 inches. At least on my screen, that's what it is. So it is going to be skewed. It's going to look more like an ellipse, but in reality, this really is a circle. It's a 4-foot diameter culvert. There's 2 of them stationed at 45 and 55 feet along the stationing here with an invert of 40 feet, both at the upstream end and the downstream end of our culvert. So we've added a culvert. I'm going to go ahead and just make one more culvert and demonstrate just a few of the other values that we could have used instead of 2 circular culverts. Let's go ahead and put 3 box culverts on top, just kind of up in this area right here. Maybe not a very realistic design, but as far as getting to understand how to use HEC RAS, that's the whole purpose of this lesson. So I'm going to use this existing River Station 150 structure and add more culverts. So let's click on the culvert editor. Now, instead of culvert 1, I could make a copy. In fact, let's see, this one's copy right here. That may probably be a little easier. So let's see what happens. Okay, so everything copied over. Now it's called culvert 2. I've got a culvert 1 and a culvert 2. Whichever one is selected is the one that I'm making edits for. All right, so what do we want to do here? Let's just work from top to bottom here. The shape is going to be a box. Let's say this is 5 feet wide by 5 feet tall. I'll just go ahead and accept the default chart and scale without actually thinking too hard about it, even though this is important to get right once you're actually building a model. The downstream distance will be 30. The length will be 40. That's all the same. Entrance loss coefficients, that's fine. I'll just assume this is concrete again so that Manning's End makes sense. Okay, I'll leave that information the same. Now the invert elevation will be different because I want this to be higher up. Let me move the diagram over. Okay, so maybe an invert a little higher. So 40 plus 4 would be 44. So maybe an invert of, how about 50? I'll say 50 here and 50 here. And now what I want to do for the different culverts is I'm going to have 3 culverts, and the middle one's going to be stationed at 50. That's for sure. It's going to be centered. And then the other 2 are going to be, we'll just say 8 feet off from center. So 42 and 58. And then click OK. Does that look good? Okay, that looks good. Again, these are supposed to be box culverts of square shape, but they don't look square simply because the scale is a little bit off on the horizontal versus vertical. I can go ahead and make them more vertical looking. So maybe I want to make them 10 feet tall. Click on the culvert button, select culvert 2. Okay, that's already selected. And then the rise here wouldn't be 5, it would be 10. I click OK. And then they all increase. So they're now 10 feet tall, 5 feet wide. And again, they're above the 2 circular culverts that we added previously. Okay, well, that's the editing and adding culvert part of this lesson. Something else I wanted to mention before moving on is the view and options values within the Bridge Culvert Data Editor. So if I click on view, for instance, we can zoom in on this right here if I wanted to get a detailed view. And then I can hold down the shift button and pan around. As you see, I'm panning on the top, but the downstream pan is also responding just the same. And then I can go view, zoom out. I can go view full plot, which is nice. If I zoom in a lot, like I zoom in on something small right here, I've got the mini map to the side, so I can drag around the little red frame within the mini map to sort of reposition my view that way. And then pan. This is how to lock the pan hand, but just as before, with the main geometric data editor. If you just hold down the shift key, that will automatically toggle on the panhand. So right now I do not have the panhand enabled, but that's not a problem. I can just hold down shift and then the panhand appears. Okay. I like clicking on view and then full plot unless I have reason to zoom in on something. Okay, after that, we can view just the upstream face of the structure or just the downstream face, or what I had it at was displaying both. And then we can also view a grid right here. And we can turn on the grid lines if you want to look at it using a grid view. That reminds me, I never actually drew in the bridge structure. So if I toggle off grid, let me just toggle those off there. Okay. Road, bridge, deckway. Let me go ahead and add some numbers right here. No, because there's actually nothing right here. There's no bridge structure or bridge deck. Okay, so this is going to be from 0 to 100 feet as a station, and then 0 up to 108 feet as the chord height. I'm going to copy that downstream and then click OK. Okay, so that's now filled in. So we're looking upstream or downstream, and then we have the car traffic up above on our bridge, and then the water flowing through these culverts. All right, so we talked about view options, the view menu. Now the options menu. We can add a bridge or culvert. We already did that at the beginning of the exercise. We can copy a bridge or culvert. So if I did that, what I'm copying is the bridge or culvert structure that I have currently selected. So the only one we have here is the one that's selected. But if I wanted to reposition that maybe 100 feet downstream so that it's centered between these two cross sections, then I would just say 50 instead of 150 and then click OK. And I believe, yes, it is created. Now for this plan view map to get updated, I think I just need to close this. Okay, there it is. So this is probably not something you would actually build, but this is now two separate structures with two separate culverts each. So I'm going to go ahead and delete that. Bridge culvert. Now I need to make sure to select the correct one. This is going to be the one centered at station 50. Options, delete bridge or culvert. And I need to confirm, yes, reach one, the one at station 50, and yes, it's gone. Okay, so it's no longer on this drop down, but it still shows up in this display. I kind of wish that it would refresh this display just mentally. I know it's gone, but I think if I just close this editor, okay, it's gone. Bridge culvert. Okay, we're back. Next on the options menu is internal bridge cross sections right here. This option allows the user to change the station and elevation data, roughness coefficients, and main channel bank station for each of the two internal cross sections, the two cross sections that you're seeing right here. Okay. The next option down is momentum equation. This option allows the user to add in the friction component and weight component of the momentum equation if you want. After that, the next option is Class B defaults. This refers to critical depth flow. This option allows the user to control where the program sets critical depth for the Class B flow, either at the upstream end or the downstream end. So you can go ahead and make that selection. Granted, critical flow may not occur within the structure itself, so that may not be relevant. All right, next down in the options tab is the pressure flow criteria, which is this one here. This option allows the user to select either the energy gray line or water surface elevation to be used as the criterion for when the program begins checking for the possibility of pressure flow. Personally, I think it should always be energy gray line, so I'm at least glad to see that that is the default value. All right, what next is the ice option? This option allows the user to select how ice will be handled inside of the bridge during ice computations. So there's either no ice, constant ice, or dynamic ice are your options there. And I know I'm kind of just going over these quick, but we can talk about them in more detail in a later lesson. And then the last option here is skew bridge / culvert. This gives the user the ability to modify the skew angle from 0 to 45 degrees for either the deck roadway or the piers. If you happen to have any piers, you would type that value in. This option allows the user to make adjustments to the bridge / culvert data that happens to be skewed, because that would affect the flow. All right, well, that was it for this lesson on entering and editing culvert data. We added a bridge deck roadway, added some culverts, and then after that talked about some options under the view and options menu.